Okay, Catherine, do you want to kick us off and we'll get started?
I will indeed. Hello, good evening, good morning, good afternoon to wherever you're coming from, and welcome back to the Genomics and Health Implementation Forum, Day 2. Now, those of you who were with us yesterday, we had a wonderful program that covered everything from gene curation, looking at approaches to data storage, enabling clinical data exchange. And today we have another great program where we're focusing on areas of common interest around regulatory and ethics, quality control of whole genome sequencing results, and then a series of different initiatives demonstrating their end-to-end implementations of Global Alliance standards. And then finally, how to get started with the Global Alliance, the GA4GH starter kit, to simplify for you how to implement the standards associated with the GA4GH. Now, yes, I do have control. On behalf of myself and my co-chair, Mark Caulfield, it's really great to welcome you. And I'll just also get Lindsay to talk to you about how we manage Q&A during this seminar. Lindsay?
Sure. Yeah, so just very briefly, if you were here yesterday, hopefully you know how this works, but we'll be using an app called Slido. So if you type slide.do in your web browser, it will take you to the Slido homepage, and then you can enter in the box the event code #GHIF, and that will bring you into our Slido web interface. And so using that web interface, you can type in your questions, either with your name or anonymously, however you prefer, as well as upvote others' questions. So we'll be using this to manage questions throughout the webinar, and feel free to go in there and ask questions anytime. We'll be getting to all of the speakers' presentations at the end of their session, so hopefully it generates some good discussion. And if you have any trouble throughout, just send me a message in the chat and I'll help you out.
Great, thanks very much, Lindsay. So there's some more instructions there around using the raise hand button if you'd like to make a verbal question. And also you can put things in chat, but it's much easier if you use Slido. Okay, so our first session comes to us from the Regulatory and Ethics Group, which is looking at the challenges and solutions in genomics around return of results policy, data access committee review standards, and DPATH. And our first speaker will be Anna Lewis, talking about return of results. So over to you, Anna.
Thank you very much. It's a great pleasure to be here. So next slide, please. I'm going to be talking about a new GA4GH policy on the return of results to research participants. And this is a result of a task force co-chaired by myself, by Bartha Noppers, and by Robert Green. So next slide, please. So we have an emerging ethical and legal consensus supporting the return of clinically actionable results. There are actually multiple ethical appeals one can make to support this. We can appeal to the rights of participants, for example, the right to access or the right to be informed, to the duties of researchers, for example, the duty of care, the duty to warn, the duty of rescue. We can appeal to the value of reciprocity, and direct appeals to beneficence, that is doing good, are also part of the picture. The legal landscape is also very supportive of returning results, and in many cases it is mandated. And here's a review from Adrian Thorogood and others from 2018 of the international landscape. And then specifically in the context of genetics research, the Council for International Organizations of Medical Sciences, in collaboration with the WHO, stated in their 2016 report, there's an emerging consensus that at least some findings in genetic research must be returned to individual donors if they wish, and that life-saving information and data of immediate clinical utility involving a significant health problem must be offered for disclosure. Next slide, please. So this return of individual research results is part of a cultural transition in the research enterprise. We used to talk about research subjects. Now we talk about participants, and some studies talk about research partners. This trend includes participants becoming more involved in research and respecting them as partners. And this systematic review of the literature, actually Veers et al. Is just out, another GA4-GH led effort by Dania Veers, shows that individuals highly desire return of results. Next slide, please. So this GA4-GH policy aims to provide a reference point for the management of return of individual research results and to identify common ground while allowing for appropriate customization. And it recognizes the importance of the accountability and transparency of genome researchers towards participants. Excuse me. So we have a set of policy points. The first might seem obvious, but it is a clear protocol that is adhered to. This is to promote transparency and also accountability. And putting return of results in the protocols, some of us felt on the task force is often seen more as permission by researchers to return results rather than an obligation, and that needs to change. Next slide, please. Upfront resourcing. So for the sharing of genomic data, GA4-GH has insisted that this be a line item in research budgets. And we're saying that the same ought to be here true for return of results. So this is upfront resourcing, both for the full process and also the personnel that would be needed. Next slide, please. Okay, so our third policy point is a link to clinical standards. And this allowed us to square a circle that I'll explain in just a second. So the policy states, in deciding the parameters for return of clinically actionable genomic results, researchers should be guided by current practice regarding the clinical standard of care within their jurisdictions. Justification for this is it's the prospect of a clinical action that motivates such return, that the relevant clinical standards will be appropriately sensitive to the health system context, and also the blurring of the research clinical divide. And we were finding that the very diverse clinical context was driving a lot of the disagreements we were having as a task force and about appropriate return of individual research results. So this link to clinical standards allowed us to square that circle of divergence internationally. Next slide, please. Fourth, that the development of the return of results policy for an individual project should be guided by community engagement where possible. There are lots of questions about what should be returned and how. There's a massive literature on how projects can engage with the community in order to answer some of these questions. And next slide, please. There's a great resource also from the GA4-GH, a framework for involving and engaging participants, patients, and publics. And I'll point you to that. Next slide, please. Fifth policy point, sharing of resources. As projects put together their return of results policies and then enact them, they generate a lot of resources that can then be shared. So that ranges from the consent form that a lot of sweat and tears go into putting together, as well as tools for measuring outcomes and various other things that might all be part of a return of results policy. We ought to share those. Next slide, please. And finally, funders are urged to support the return of results. So evidence suggests the existence of a large gap between what researchers would consider best practice for returning results and what's currently being implemented. And additionally, such funding would generate data that we sorely need on cost to benefit and risk to benefit of returning genomic information. And the gathering of this evidence supports the human right of everyone to benefit from science and its applications, the fundamental philosophy that animates GA4-GH. And next slide, please. I'll just leave you with this. So before you gather any data, implementation projects need to consider return of results. There's just no way about that. This is true even if you decide that there are no circumstances whatsoever under which you would return results to participants. You still need to go through the process of outlining exactly what your policy is with regards to return of results to research participants. The legal requirements for returning results are backed by ethical requirements. And so we're really hoping that people use this new policy as a framework alongside relevant legal requirements and local clinical guidelines and best practices. And I'm going to put the links to the policy in a write-up in the chat. Thank you very much.
Great. Thanks so much, Anna. And now we'll pass on to Ted Dove, who's going to talk about the Data Access Committee guiding principles.
Thanks very much, Catherine. Good to be with you all today. My name is Edward Dove, or Ted Dove, as you heard. I'm a lecturer in health law and regulation at the University of Edinburgh, and I'm presenting today on behalf of my colleagues Vaso Rahimzadeh at Stanford University and Jonathan Lawson at the Broad Institute of Harvard and MIT. And I'm delighted to speak about the work that we've done across two work streams: the regulatory and ethics work stream and the data use and researcher identities work stream, the DURI and RUSE, namely concerning data access committee guiding principles and procedural standards policy. Next slide, please. And to provide an overview about why we had the need to devise this policy, I want to go over a couple of points. I'm sorry I don't have the little icon I can't see on my screen, so apologies if I say suivant next a few times. Suivant next, please. So I suspect, as many of you are aware, there's different methods for accessing genomic and health related data. And this is one schema, and obviously a very simplified schema, but the primary ways in which genomic and health related data can be accessed is open, available to the public without restrictions. Generally, that is, of course, fully anonymous data. There might be subject to some conditions, but in principle, the data is open and available to various uses or conditional uses. There's an emerging approach called registered access. So researchers who have authenticated credentials, and a lot of the work that's being done at the DURI workstream and the RUSE has been looking at registered access for that. So proving your bona fides, and then finally controlled access, which is often making a data available to users after receiving data access committee approval. Next slide, please. And next slide, please. So the process, again, a very simplified schema, is that the researcher applies, demonstrating their credentials to the committee to say, this is who I am, this is my research project. Very similar, of course, but still distinct from the application process for research ethics. But going through demonstrating the appropriate methodology, the research question is a legitimate scientific question, and that you need access to these specific data. Next slide. The researcher puts together the application materials, and essentially the question being asked by the committee, is the requester appropriate? And now, is the data request appropriate? And then thirdly, next slide, ensuring by the data access committee that request complies with any data use restrictions being put on the data. In other words, is the data project appropriate? And all three of those questions are going to be at the forefront of the data access committee's mind. Next slide, please. However, one of the reasons why we wanted to develop this group is we think that there are concerns or drawbacks to the existing approach across data access committees, very similar to the reasons why we decided to do ethics review equivalency work a few years ago within the regulatory and ethics workstream. Static approaches to data generation and manual verification, particularly regarding data use restrictions and verification of those restrictions, might not be compatible and fully compatible with demands for real-time access to data sets hosted in complex or dispersed computing environments, so cloud computing environments, but also entirely human-mediated access restrictions and assessments can lead to inefficiencies and inconsistencies, not to mention error. And given the proliferation of DACs across multiple data custodian bodies globally, that can create a number of systemic inefficiencies and inconsistencies. Next slide, please. So the impact, next slide, please, is that we wanted to develop a policy between the RUSE and the DURI that could help better coordinate DACs along with other similar bodies like ethics committees, lowering the time and resource burdens for data access by pruning redundancies where we could see them, and optimizing utilization and sharing of existing data resources, hoping ultimately this will lead to broad improvements of the efficiency of data access review across international DACs, both within organizations and globally situated ones, by uptake of this policy. And we also think that ultimately it can lead to a quality improvement and evaluation agenda for access committees, and that addresses the need for greater transparency and indeed in data stewardship. Next slide, please. And so in terms of the end users that we hope to have involved, next slide, please. We hope that the policy will have applications of repositories, managing organizations, universities and public bodies, data stewards, so we identify as DAC chairs and members, privacy boards and other compliance officers, as well as research funders and sponsors. Next slide, please. In terms of the next slide, please. In terms of the approval process, we, in our Data Access Committee work group, a Data Access Committee Review Standards work group, nicknamed DACRES, and you can imagine why we came up with that name. Really a global initiative from across multiple continents, bringing together expertise in data access committee review standards from a lot of our core members in the Global Alliance. Next slide, please. So the ultimate purpose then of this policy was to develop guiding principles and provide procedural standards, not substantive standards, but procedural standards for DACs that complements the framework for responsible sharing of genomic and health-related data, as well as the other policies that we promulgated within the Global Alliance. Next slide, please. And the scope is that we recognize there is differences in the contents and application of ethics principles, policies, and norms that necessarily will arise locally amongst institutions, repositories, and jurisdictions. But these differences, we believe, are not insurmountable barriers to achieving harmonized guiding principles and procedural standards for data access committees, similar, as I say, to the work we did in ethics review equivalency policy a few years ago. So what we aim is to develop both essential standards and desired standards that DACs can adopt as contextually relevant for their needs and interests, as the case may be in their particular circumstances. Next slide, please. So very briefly, because I know this is a very 5-minute whirlwind, I'm wrapping up in just 30 seconds. This was a long journey where we started in May 2020, right in the midst of the pandemic, and all of our work was done virtually by correspondence, by Zoom calls, where we formed an initial meeting of the DACRES group, did a mapping exercise, collecting existing data access committee policies, SOPs in terms of reference, had an initial draft, iterative forms of policy development, ultimately putting the policy out for public comment in July and August 2021, and then achieving steering committee approval by the GA for GH last month after multiple iterative rounds. And that's where we are today. Next slide, please. So I won't, and I don't have the time to go over details similar to what Anna's done. I will put in the chat the link to the policy. But you see here the preambular text that sets out the reasons and the rationale and justifications for developing this guiding principles and procedural standards policy. And on the right-hand side of the screen, you see the structure of that policy. We try to develop core standards that we think can drive consistency and ultimately efficiencies in the process for data access committee review by covering purpose, transparency, terms of reference, SOP, criteria for assessing applications, progress reporting, data management incidents, and thinking about DACs as living and learning organizations. Next slide, please. Next slide, please. Last slide, which is this. Great news. So we've received an administrative supplement from the National Institutes of Health, namely NHGRI, to further develop the work within our the Data Access Committee's work group, building on the policy that we've just had finalized, namely by testing it within the AMBO, which is a broad focused group, as well as the project, as to say, as well as the driver projects within Global Alliance, to try to build out further tools that can emerge from this policy. And we'll be doing so through some surveys and interviews with DAC members, both within the US and internationally, to identify existing challenges and opportunities, particularly thinking about automated approaches to data access review to supplement the human decision-making components. So exciting times, the work continues in the Data Access Committee review group. So thanks very much. Apologies for the whirlwind, a lot to get through.
So it was a whirlwind, Ted, at 11 o'clock at night in Australia, but really appreciate the depth of thought that's gone into these policies. And the last speaker, before we go to questions, so do put questions into Slido, is Palmira Granados Moreno, talking about data privacy assessment tool for health. Over to you.
Hi, good morning, everyone. As it was mentioned, my name is Palmira Granados Moreno. I am an academic associate at the Center of Genomics and Policy at McGill University. And today I'm going to talk to you about this tool that we have developed that is called the DPAS, or that stands for Data Privacy Assessment Tool for Health. And next slide, please. So today I'm going to talk to you specifically about the original context in which DPAS was created. This was EpiShare. Then we're going to talk to you about the objective that it follows, the main reason for which it was created. And then I'm going to walk you through its path, how it works, and how it looks like, what it's composed of, and what it's intending to do. And then I'm going to briefly refer to its geographical coverage. Next slide, please. So starting with the regional context. Next slide, please. DPath was created in the context of this project called EpiShare. EpiShare is mainly an open science platform that is used to enable users to securely share epigenomic data. It was created in combination by the Canadian Centre for Computational Genomics and the Centre of Genomics and Policy. You can see their links here in the bottom. Next slide, please. So basically, what EpiShare is, in like very simple terms, is like a search engine, like a Google for users to search for epigenomic data anywhere in the world. With the impressive achievements that EpiShare brings, it was also obvious that there are several challenges to sharing data. So with the advancement of technology and science, it was clear that there were challenges in terms on what are the tools that are being used to share data. It was also clear that all the different types of data created a variability in data access processes. And given the global aspect of data sharing today, there was also diversity of privacy legal frameworks that needed to be addressed for data sharing to be in compliance with all the ethical and legal matters. Next slide, please. So in this context was that we created DPath. As I mentioned, DPath stands for Data Privacy Assessment Tool for Health. And this, the name intends to limit or to clearly define what is the objective and what is the context or the limitations or the restrictions in which DPath works. So on the one hand, it focuses on privacy, and on the other, it focuses on the data that is being used for health. Next slide, please. So I'll share the link to DPath in the chat as well. And but basically, when you start playing or using DPath, you can see that this is how it looks like. Next slide, please. So if you remember, I mentioned that the name had the purpose of limiting or clearly defining what was the purpose of it, and it is to protect privacy. Next slide, please. So given that it intends to ensure compliance with applicable ethical, legal, and professional privacy norms, we're going to be looking specifically at what are the requirements to comply with these norms with respect to personal information that is being shared when people are sharing their health data. Next slide, please. So now we are moving on to DPath. So how it works, what it is composed of. Next slide, please. So DPath is composed of easy lay questions that all of its components have also easily accessible and on-the-spot definitions of the relevant terms. And then at the end of all the answers that the user provides to these easy lay questions, there is an output of the list of requirements that the user will more likely will have to comply with. This list of requirements is organized both in categories and also in the extent of compliance that is expected. An important thing that that we need to keep in mind is that DPath is by no means any legal advice. It's just kind of to get the user started into what needs to be considered. And then we encourage the user to look for legal advice, to professional legal advice, to make sure that they are in fact complying with all the legal requirements. Next slide, please. So the first set of ECLA questions refer to the relationship of the user with the data. So we have two options here. The user could be a data donor, or they could be a data steward or data user. If the user is a data donor, there are no further questions. It directs the user to the contract and to the best practices, as you can see by the colors that we're using in this slide. However, if the user is a data steward or a data user, there are further questions that need to be answered. So the first question after that would be, where is a project or organization located? So for this, we have the options, the specific options of Canada, the US, and the EU, and then we have an option for other countries in just like a drop-off menu. Then the next question would be whether the user is somehow monitoring behavior. And if that is the case, then we're asking where the individuals whose behavior is being monitored located. So the answers to this question would be first yes or no, and then if it would be whether they're located in the EU or not in the EU. And then the last question would be, are results being returned? And if so, then where are these individuals located? So again, the answers would be yes and no. And then it would be in the EU or non-EU. And this is because of the provisions and the scope of the GDPR, the legislation in the European Economic Area.
Palmira, I'm going to need to ask you to wrap up because we're over time.
Yeah. Next slide. So then the next set of questions refer to the type of data that is being shared. Next slide. And then because, as I mentioned, it was BPAD was created in the context of EpiShare, we ask specific questions with respect to Canada. Who is the person processing the information and what province? Next slide. Then it gives you a summary of the answers, and then next slide. It then goes to the list of requirements that I mentioned. It composes, or it also comprises the laws and best practices, and then it gives a specific obligations categorized in this accountability, lawfulness of use, storage, transfer and protection, and security and safeguards. Next slide. The target audience are data users or data stewards, and this definition of this term is included in DPAD, but it basically covers researchers, data hosts, service providers, and such as cloud computing services. Next slide. So with respect to the
no, I'm going to need to stop you there, Palmira.
This is the last one. Next slide, please. So it just covers, as I said, Canada, specifically Quebec, and Europe. And this is the last one. This, as I mentioned, this is the link. It's in the chat, and thank you very much.
Great, thanks. If we could bring all the speakers back, we've got, we'll allow time for 1 or 2 questions, but we will need to move on. The question to Anna, do you envisage return of results to be a one-off task, or would you also encourage recontacting if there's actionable knowledge in the future?
We would encourage a research project to carefully think through that question in advance of it landing on their desk. And I think you could argue this either ways. And one thing to note is that there aren't any responsibilities post the end of research funding. So that also has to be incorporated into the policy.
Right. But one question I had for all of you, and Ted, I can't see you on the screen, but I think we're all used to return of results in the setting of, rare disease, for example. But as we're trying to scale up to population level data, as we will be sometime in the future, do you see that these tools are going to be able to be adapted to expand to that sort of scale?
I definitely think so for the return of results policy. It's all hinged around the idea of clinical actionability. And so once you get polygenic risk scores, for example, really into that clinical actionability realm, then exactly the same things apply.
Right. And Ted, any comments from you from the data access perspective?
Well, I mean, yes, I mean, certainly that is the hope, Catherine. And then just looking at Melanie's question too, again, to be short, yes, that is the plan. We want to have metrics to evaluate compliance levels, and that's part of our hope within the administrative supplement to be able to do so under the DACRI's toolkit. So stay tuned, and that is the work on goals within data access committee review standards.
Great, and just finally to Palmyra, the reach of DPATH, which is incredible, knowing what we have to navigate from a compliance perspective in different regions. Are you seeing this expanding so it's going to be relevant to all of us? Like it was really great in Canada.
We started originally just with Quebec, and then we started expanding to other provinces. We have provisions also for the GDPR, so everything that relates to the European Economic Area. We have some references to also the US, and the idea of using this drop-down menu is that we are going to be able to see where the users are coming from, and eventually devote resources to exploring the specific obligations with respect to all these other jurisdictions that get kind of like more votes in the future.
So it gets to be an incredibly valuable tool. So thanks to all of you, and we recognise the incredible amount of work that's gone on behind all of these great policies. So thank you. I'll now hand over to my co-chair, Mark Caulfield, to take us through the next session of quality control of whole genome results. And I would just check with Lindsay and Justina. I believe our speakers should be able to take over control of the screen. Is that correct?
That's correct. We can pass control, yes.
Great. So over to you, Mark.
Thanks, Catherine, and thanks to all the speakers in the last session. Without further ado, I'm going to move straight on. We've got two great speakers. Because it's really late at night in Singapore and Australia, we invited Mar Gonzalez Porter and Oliver Hoffman to take us through this important area. So over to you, Mar and Oliver.
Thank you so much. I think I want to start. Yeah, are you there, Mar? Brilliant. Okay, Mar and I are going to provide an update on the quality control pilot. And this is on behalf of the whole working group. It's very much a joint effort between different initiatives. And I'll come back to that in a second. I'm going to start with a quick recap of the project if you had not heard about it before. The working group is trying to come up with specifications or a unified language, if you will, for quality control metrics of high throughput sequencing data. It's a bit of a mouthful. The underlying idea is that we all understand that having good quality data is really an important starting point for pretty much any research project. It's key to being able to trust your results. And so accordingly, as our data sets grow, the cores increase in size and in complexity, and we're starting to combine data sets across different research organizations, it's becoming increasingly important to make both the data and the final results more comparable. And there's been a number of efforts to harmonize sequence analysis workflows. Some of them are still quite active. There's been the concept of functionally equivalent workflows that's been proposed back in 2018 by a number of different sequencing or major sequencing centers. That's probably the best known efforts. But there's also orthogonal initiatives that try to improve the overall sequencing quality. Genome on a Bottle, seq-C2, or attempts to reanalyze data with reference sets to have an amount of quality control. But as Daniel MacArthur actually pointed out during the session yesterday, there are still use cases where we want, maybe even need to reprocess data using the exact same workflow, just to minimize any artifacts in the results. And G4GH standards, just as WES and workflow languages, be it CWL, WDL, Nextflow, make that a lot easier these days. We don't have to move petabytes of data around. But ideally, we'd still like to run those workflows just on the data sets that meet our relevant study criteria. So running your workflows on low coverage samples or poor quality data sets is, well, it's wasteful. It means you have to process the results. You have to filtering and QC of the primary data. But also, if you don't catch it, can result in biased results at the very end. So to tackle this problem, the working group is trying to come up with a set of agreed upon definitions, really, and parameters to calculate QC metrics upfront and leaving the actual implementation to the data provider. And the idea is that those metrics are accessible to the data consumer along some of the primary data just when they decide which cohort or which subset of a cohort they want to run the analysis on. And so when we started comparing metrics generated on the same quality control name between different organizations, we quickly confirmed that implementation details and the definitions actually differ. What two organizations define as genome coverage of level X or quality score of 30 can be surprisingly different. So as a goal, the project has a number of different deliverables. First, we'd like to come up with a set of standardized definitions for those quality control metrics and the relevant parameters, so basically the context of the metadata for those. We'd like to, second, come up with a schema that captures this information and makes it able to share the results in a uniform way. We'd like to offer a reference implementation that interested parties or initiatives can run across their cohorts. And we'll hear about the GHIF toolkit or toolbox a little bit later during the session. So we're hoping fully be able to make it available to that venue. And finally, offer benchmarking data for the official QC metrics, data and what results should you achieve if you want to go for an independent implementation, or just to come up with new metrics and tests for consistency. So in brief, the idea is to come with a language that clearly defines those QC metrics for cross-organization description without being really prescriptive what are the Q steps you should be running, because that's going to be very, very different for each organization. And as I mentioned at the start, this has been very much a group effort. We had participants from obviously Precise Singapore, CGen All for One Canada, Ufamatics Finland, the Qatar Genome Project, Australian Genomics, I think I should mention. I hope I didn't forget anyone here. And to keep this somewhat tractable, for the first phase, we focused on whole genome germline sequencing only. At some point, we'd like to expand the scope, and we could really use help and expertise of other large-scale initiatives, be it with the design of metrics definitions, the implementation, or the willingness to run this across other cohorts. So if this sounds really remotely interesting to you, please get in touch. Just send an email to Lindsay, or I'll put those links into the chat in a second ago. Over to you, Mar.
Thanks, Oliver. Could you switch to the next slide, please?
All right, and then I think Justina will hand it over to you.
Perfect. Thank you very much. So we also wanted to take the chance to share with you some of the work that we've been able to do till the day today. And one of the main activities on that regard is working towards a proof of concept exercise. And the idea there is to try to illustrate some of the challenges that Oliver has mentioned in his slides. So as you can see on the left, the actual design of that proof of concept is very straightforward. We start with a publicly available data set for NA12878, which is one of the genome in a bottle samples. And the idea is to make that data accessible to the various participants for them to take VAM and VCF results and push them through their in-house QC pipelines with the goal of comparing the outputs of those pipelines. And actually on the right, you can see some examples of what we're seeing now that we've started doing some of these comparisons. So for example, when we look at the results for coverage submissions, we've got here the results for a couple of participants, and we can see how they actually disagree quite strongly on the actual value for that coverage metric with a difference of above 4x. So typically you would stop there, you would see a difference in metric value, and you wouldn't necessarily know what is driving that difference. And that's what we've been discussing and trying to get to with the QC workgroup. So without going into detail, what we've done here is we've listed some of the variables that we know contribute to the coverage calculation. And what you can see highlighted in blue are the ones where the two participants differ. And you can see that it's pretty much the majority of them. So talking things like the genomic region that gets included in the metric, thresholds for mapping quality, and so on. So altogether, we think this example for this metric illustrates very well what Oliver has mentioned before, that it is indeed necessary to have guidelines that exemplify or suggest which QC metrics to track. But in our experience, that's often not enough, and we need to take things one step further and also try to standardize definitions. So I'll move on to the next slide to talk a bit more again about the work that we've been doing. So using this proof of concept as an example, we've also been able to brainstorm about which are the fields that we consider that would be useful to track together with the actual QC metric and values. And we're compiling thoughts in a document that's publicly available online, so open for comment if you're interested to contribute. I'll just mention quickly one of the reference implementations that we're proposing to adopt for the example that I was showing before, and that's the one around coverage. And as I said, typically you would just report the metric name and the value. We're proposing here to expand things slightly and include, for example, free-form description and source information, as well as a more standardized section that tries to provide more visibility on what went into the calculation of these metrics. I'll just say this work is very much in progress at the moment. A couple of ongoing discussions that you can see here is we're still debating which fields should go into this more standardized section. Some ideas you can see listed in the slide. And also we're currently debating what's the best way to capture the fact that people are using custom genomic regions as opposed to the entire genome. And that's an area where we hope we can learn a bit from the experience from other GA4GH work groups. So with this, we'll just wrap up with 3 take-home messages. So number 1, we do think QC is important, especially in the context of large-scale initiatives, like pretty much the audience here. But often, in fact, that there's a lot of published guidelines. Often these guidelines, in our experience, are not enough, and it'd be good to also have standardized definitions to guide their implementation. That's why we started the QC workgroup, a collaboration with various national scale initiatives to try to come up with this unified language. And so far, we've started focusing on BAM-CRAM derived metrics. But as I said, very much work in progress. And one of the things that's become very clear already is that every initiative has something to bring on the table, a slightly different perspective on things. So if your initiative is facing similar challenges, if you feel that having a standalone QC pipeline that you could run would be useful to you, or if it wouldn't be useful, we'd love to hear from you. And so we're wrapping up, we're going to wrap up with the contact details that you can see on the slide. So from there, happy to take any questions.
Thanks, both of you, for fabulous talks. Let's take a look at what's in the Slido coming in. How many groups have you guys got involved in this discussion and debate at the moment, Mara and Oliver?
I'm going to say it's 6 groups plus a couple of people who are dropping in and out, but we can say 5 or 6 groups that are active participants. More are welcome.
Oh, that's great. So, guys, if any of you want to join Mara and Oliver, this is one of those tasks. More eyes are helpful. So we'll go to the chat and look at the Slido. So to both of you, is it a goal of the project to make WGS-QC a GA4GH standard?
Shall I jump in, Oliver? I would say this is quite an ambitious goal. For now, we're seeing where things go. The immediate goal would be to come up with this standardized language, and then we do hope to learn and engage with GA4GH, and Oliver has been pretty active on that end. So who knows where it's going to take us, but what do you think, Oliver?
Yeah, I think we'll have to see how it develops. There's at least coordination with some groups like large-scale genomics, for example. How do we transfer this information? Is JSON the right part? Should some of this be part of a BAM or CRAM format spec? Yeah. How does it get encoded? Beyond that, we'll see. And then quickly to Augusto, yeah, right. So I posted links up. It's just not the bit links, it's the expanded links, Augusto.
And but Oliver too, could a use case for these be an EQA scheme?
Absolutely. That's very much one of the use cases that we've been discussing. And in fact, the comparison with U-Formatics has been very much motivated by EQA schemes. They have a lot of experience in running those and have also run through lots of challenges when it comes to comparing results from many different participants.
Thank you both. That concludes the questions. Superb presentations, and thanks, Lindsay, for putting the links in the chat. We're going to move directly on, but thank you both. Please volunteer to help Mar and Oliver with this important task. So thanks, guys. I'm going to take you now to the next session, which is end-to-end implementation of GA4-GH standards. And we're going to start with Japan Biobank, and it's my pleasure to introduce Yuichiro Kamatan from the Japan Biobank to speak to you. Over to you, Yuichiro. Do you think, Lindsay, we ought to just move to the next presentation in case?
No, I think Yuichiro is here. I see his mic is.
Yeah.
Oh, so there you are. Great, fantastic. Welcome. The floor is yours.
Hi, this is Yuichiro. Can you hear me?
Yes.
Yeah, yes. Thank you. Hi, good morning and good evening, everyone. My name is Yuichiro Kamatani from the University of Tokyo. And thank you very much for inviting me to this great meeting. And I will introduce our Biobank Japan. And on behalf of Biobank Japan's steering committee members as shown, and the representative Professor Yuji Yamanashi. Yeah. So what is Biobank Japan from the viewpoint of GA4-GH? I think that we are a component of the research part of the GA4-GH driver project, GEM Japan. And the Biobank Japan is somehow old biobank launched in 2003 as a large patient-based biobank. And please have a look on this Nagai et al. Paper for further reading. The founder of this project is Dr. Yusuke Nakamura, now at the Cancer Institute for JCR in Japan. And the current leader is Dean Yuji Yamanashi, the Institute of Medical Science, the University of Tokyo. And the Biobank Japan is a patient-oriented biobank. And to collect biobank materials, Biobank Japan collaborate with 12 medical centers and 65 hospitals from north to south in Japan to cover genetic diversity of Japanese population. And finally, we collected 267,000 patients from these hospitals finally agreed to join this project, and 200,000 between 2003 and 2008 as first cohort, as shown at the upper triangle, and 67,000 between 2013 and 2018 as second cohort. And DNA samples were collected from all of them. And also serum samples for the first cohort, and clinical information for both cohorts were collected each year. However, since this is a real-world data collection, when the patients skipped to come to the hospitals at a certain year, we could not collect that information. Similarly, if the patient stopped to come to the hospital, then we could not follow them. But anyway, finally, the mean follow-up period was around 10 years for every patient. And we also gather the information from local government as well as national registry to obtain this record of the Biobank Japan participants. And actually more than 30% of followed up patients were already dead. And survival curve indicates that females are more likely to, females are less likely to die earlier than males. And also older patients are likely to die earlier as expected. And the proportion of the cause of death from the whole vital statistics Japan indicates that malignancy is the leading cause of death in Japan. And compared with that data, the Biobank Japan participants seems to be more likely to be died for malignancy. And not only the patients with malignancy, the patients registered for malignancy to Biobank Japan, the patients with liver disease, metabolic disease, respiratory disease, cerebrovascular disease, and musculoskeletal disease patients were also died for malignancy as a primary cause. Only the cardiovascular disease patients were died for cardiovascular disease itself. And these are the list of diseases for Biobank Japan first cohort. As you can see, some specific diseases were selected, which were considered to be important for the public health in Japan. And using these phenotype data, we have published several genome-wide association study, like atrial fibrillation and type 2 diabetes, and coronary artery disease. And although the sample sizes of these studies are smaller than those of European ancestry, we found many novel susceptibility loci for complex diseases. We think delineating the importance of GWAS in non-European ancestry. And relevant medical record information of BBJ were collected like this story in Japanese. In Japan in 2003, when BBJ was launched, many hospitals still use paper-based medical record. So we put medical coordinators at each hospitals, and they copy the data to input forms and send it to BBJ. Obviously, this process should be done electronically and automatically. But anyway, the researchers use this information and to make some publications like BMI and 58 laboratory tests, GWAS, and age at menarche, menopause, GWAS. And then with these results, we tried to collaborate with international researchers. To be honest, we cannot completely share the genetic and clinical information overseas. Then, as is often the case, we shared summary statistics to be used in these studies. And one of the prominent contributions to Biobank Japan, I think, is that Biobank Japan data clearly showed the unstable transancestral predictive performance of polygenic risk scores. As the left plot showed, even the GWAS of 320,000 samples in European did not work better than the 160,000 GWAS of Japanese to predict obesity in Japanese. And right-hand side figures showed several traits, showed unstable performance of polygenic risk score between UK Biobank and Biobank Japan. So our main achievement is GWAS summary statistics, and we distributed them from multiple resources, GENGAR, FieldWebJP, or NBDC. And actually, within Japan, we shared individual data, and these data is used in several different studies, like the simultaneous analysis of SNP and CNA in clonal hematopoiesis, is the left article, or the Genome-Wide Association recently published at Nature Genetics. And we also started to collaborate with Nightingale Health to generate 1H NMR-based metabolomics data. We have 600,000 serum samples from 200,000 Biobank Japan first cohort patients. And actually, the similar metabolomics profiles were also obtained in UK Biobank or in FinGen. So again, this big data set would realize cross-ancestry comparison. And at the beginning, I explained that BBJ was composed of two different sets. And the genotyping of the second cohort consists of 67,000 patients were just finished and distributed to Japanese researchers and enterprises. And also, a part of them, around 6,000, were also whole genome sequenced for further research now. And then finally, I would like to explain about the future of the Biobank Japan. Next Biobank Japan will be started in 2023. And we are in the discussion of the planning of that. In this fifth phase, Biobank Japan, we are proposing an integration of EHR with the standardized collection, maybe in collaboration with GH4GH, possibly, and access to tissue samples bi-directional communication with patients, and possibility of international data sharing. So thank you very much. This is acknowledgement. That's all.
Thank you, Yuichiro, for a great talk. What we're going to do is take questions at the end. So I'm going to move us straight on and invite Christian Marshall to speak on behalf of All for One from Canada. Over to you, Christian. Thank you.
Thank you very much, Mark, and good morning, good evening, and afternoon to everyone. I'm Christian Marshall. I'm a clinical lab director and genome researcher at Sick Kids Hospital in Toronto. And today I'm speaking on behalf of All for One, which is a large initiative through Genome Canada and involves a lot of individuals, some of which I hope are on the call today. I think to understand some of the initiative, we need to think about how clinical or how healthcare is delivered in Canada. As Catherine, I think, mentioned yesterday, Canada is a system very much similar to Australia. Healthcare is delivered in a provincial manner. This is data from 2020, population of Canada around 38 million. And you can see the different populations of the different provinces, which is where healthcare is delivered in these different jurisdictions. This is the clinical genome-wide sequencing that has been done. You see it's quite disparate across the different provinces. The numbers at the bottom are the number of genome-wide sequences that were sent out of country during that year. So that's roughly around 1,200 samples sent out of country. This is mainly whole exome sequencing. I'm referring to genome-wide sequencing as exome or exome sequencing or genome sequencing. And so this really means that we have a need for a national solution for the access of testing and also data sharing across the provinces. So this is really the motivation of All for One, is to get genomics into clinical care and advance the implementation of precision medicine in Canada. The goal is really to improve the health and wellness of Canadians with the serious genetic conditions by enabling this access. I think timely and accurate genomic-based diagnosis is important, and to have some equity across the country. So this was launched in 2018 by Genome Canada. It's a pan-Canadian initiative, really is hoping to lay the foundation for precision health in Canada. And so where is this initiative focused? Really on 6 different domains: access to genome-wide sequencing, as I've talked about, data governance to tackle social, economic, and policy issues, a pan-Canadian data ecosystem for sharing and catalyzing this innovation, rare disease cohorts to scale the data, patient and community engagement to align genomic solutions, and then healthcare professional engagement, education to optimize this delivery. Progress to date, established so far a data governance policy core, so that's this one here. I've got arrows here because these are the 2 that I'm most involved with right now. Access and ongoing work and access to genome-wide sequencing, and also the data sharing ecosystem, which we've just started. So this is what I'll be talking about mainly today. We do have a progress meeting that's planned, hopefully at the end of 2021, so just in December, it may be in January, to get the group back together to talk about these progress. So on that front of access to genome-wide sequencing, as I said, a lot of that data is sent out of country right now. It's hard to get back, and if it is, if we do get access to it, it's siloed. So right now, there have been initiatives launched to counteract this and to try to implement genome-wide sequencing in the different jurisdictions. So there's been these programs across the country. There's 6 of them. You can see the different regions. This is through the GAP, the GAP partnership program. And this is really to demonstrate the utility and expand genome-wide sequencing as standard of care. So that's one thing that's been done. and that's ongoing. But as I said, I think moving into how are we going to actually make use of this data to continue to work on it and share it across the country. As I mentioned before, the healthcare is delivered in a jurisdictional manner provincially. 10 interlocking provincial health plans, variety of different data custodians. So you can see that, again, the populations and the different regional health authorities in the different provinces. So it's quite complicated. And so trying to get a national data sharing plan together is obviously challenging, but something that it needs to be done. So this is the health data ecosystem goal. Is really to facilitate that sharing of high quality clinical genome-wide sequencing data and make it available for research, especially providing access for health research for Canadians with rare disease. What we've done is embarked on a two-pronged data solution. This includes the Rare Disease Knowledge Network. This is essentially a variant database for quality assurance and quality improvement of clinical genome-wide sequencing. And then also All for One Connect, which is more of an opt-in recontact registry for Research Ethics Board approved projects. And so the Rare Disease Knowledge Network is really meant to be essentially a ClinVar Plus variant database. And then this is, again, to ensure that we can provide good filtering of variants, prioritizing variants, and interpreting them. So this is not just sharing interpreted variants, obviously, but also sharing a lot more data so we can rule in and rule out certain diagnoses and make use of all of the data rather than just interpreted. Proposed research use cases. This is a Canadian Recontact Registry, so inviting participants directly. So essentially what we're trying to do is ensure that upon getting genome-wide data, we can sign them up for research in a registry. This is to obviously facilitate novel gene disease associations and identify eligible participants with certain diagnoses, and you can start to do things like natural history studies of a lot of these rare disorders. So the idea would be patient experience has a clinic visit. Obviously, we're getting a report, a clinic visit. They're consenting to be able to hopefully opt in to this All for One Connect. The variants in the laboratory report will go into, and the data will go into the All for One Rare Disease Knowledge Network. Obviously, this data can be shared further, interpreted data via ClinVar and other publicly available aggregate data. I've also shown the variant representation specification here, which would be a GA for GH standard that we would like to implement at this stage. And you can imagine lots of other standards that we'd like to implement across this process. But ideally, they could be recontacted and contacted directly about REB-approved research. So creating this network that feeds back into the healthcare system. And then just finally kind of ending on a broader health data ecosystem, what this is really kind of meant to look like. We imagine different tiers. So a lot of the different clinical sites, these blue dots are meant to be provincial staging centers where you can harmonize data. So a lot of clinical data sites will contribute to that. We'll have them harmonized. Because of the way the system is set up, data will often reside within the province. And so ideally, we'll have to harmonize and be able to have access to it in a more of a federated way. We've got the system in the middle that will be able to talk and then hopefully link out to many different initiatives, including, like I said, a lot of research studies. I've just sort of tagged different areas in here with the GA for GH symbol and standards. We're hoping to obviously data sharing, making use of Beacon. We have phenotype, phenopackets. Data format is obviously important, especially when we're sharing data across sites. We just heard from Mara and Oliver about genome data and quality control initiatives, so we'll be taking advantage of that. And then yesterday, there was some great discussion on cloud standards as well. And I think that we are very keen to be able to do this, which we will need to move towards a cloud-based system to be able to make this happen. So just really quickly in summary, we've launched, All-for-One launched to facilitate adoption of genomics into the clinic and advance implementation of precision health in Canada. Current efforts focus on policy, access to genome-wide sequencing and repatriating it back to Canada so that we can make use of the data, including this pan-Canadian data sharing ecosystem. And then obviously we're going to be efforts to adopt the standards from GA4GH ongoing as the initiative develops. So we're really just kind of beginning this right now. And I'd just like to end with the acknowledgements of the different leaders of the different GAP projects, the All-for-One policy toolkit, and then the health data ecosystem, which as I said is just beginning its design. Thanks.
Christian, thank you very much. Really encouraging to see the range of application of GA4GH standards. We'll come back to you in questions, but thank you for that wonderful talk. I'm going to move us now to Silica, IHCC, and invite Melanie Corto to speak to you about the activities of those consortia. Melanie, over to you. Thank you.
Thanks, Mark. Thank you. Thanks, everybody, for having me here today. At various times of the day, we're lucky in the UK, it's midday, so quite nice. And today I want to tell you about some of my work on Silica and how we deploy GA4GH standard to enable human cohort interoperability. Like many of my colleagues here, this is not just my work. I'm here on behalf of the whole consortium, and I know some of my colleagues are actually attending today. So hi, everybody. Okay, so the global context, human cohorts, I suspect most of us are familiar with several of the efforts, so of course GA4GH. We also work with IHCC, the International 100,000 Cohort Consortium, and all those efforts, ICDA, BBMI, GA4GH, and Silica, are really targeting international cohort interoperability, trying to bring the data together and benefit healthcare and leverage the amount of information for those millions of human genome we forecast healthcare will produce over the coming years. So the mission statement of Silica is really enabling that population scale genomic and biomedical data, making it accessible not only for Silica, but also across all international borders and accelerating research and ultimately having that impact on health of individuals worldwide. So again, that notion of cross-continental and international impact, which is very relevant for what we're trying to achieve here. And some of the key features of the Silica network, the scale of the network. So Silica is an effort between North America, Europe, South Africa. It includes 10 cohorts, very diverse. So some of them are disease or population, longitudinal. So 10 cohorts for just over 1.4 million participants. The whole paradigm behind Silica, because of that internationality of the consortium, is around federated analysis. And you may recognize here the GA4GH federated analysis figure of the Wes and test platform. And the last key feature of Silica is not reinventing the wheel and really leveraging all existing international standards, infrastructure, and being able to contribute back to those efforts. So some of the efforts we're working with are Candig in Canada, Elixir in Europe, H3 Bionet in Africa, and GA4GH and IHCC I mentioned earlier. So when we look a little bit at the Silica pipeline that's been developed and the plan that was made towards enabling those clinical applications down the line, obviously we start with data sources. So those are examples of some of the Silica cohorts, so the European Genome Phenome Archives and biobanks, CHILD, which is a longitudinal cohort in Canada, and H3 Bionet in South Africa. We have a structure around work packages, so where we have, for example, work package 2 deal with authentication. It's led by Michael Linden and Slavik Fischerler, and it's around, it's been implemented by Candig, the EGA. It leveraged some of the GA4GH standard like Passport, Elixir for login and AI implementation of authorization and authentication. Work package 3, which I co-lead with Fiona Brinkman at SFU, is really around semantic harmonization, metadata models. We've developed a model that represents cohort information. We're also leveraging the data use ontology and our GHIF standard that I co-lead with Jonathan Lawson from the Broad. And together, those help work package 1, which is doing a federated discovery, which in turn leverages Beacon, the Beacon API, which then includes phenopackets and includes dual terms and so on. So it's really kind of a giant jigsaw of features coming together to build that pipeline. And another standard that we're using, for example, for federated application is HTS-GET, and I will give you an example a little bit later. So that's work led by Eliza Cirillo and Carl Alasso. And so that leveraging work from the previous technical work packages allows us to deploy those federated application. And finally, as I mentioned, the end goal down the line is reaching the clinical application stage, which was just at the stage in the Silica project where we're starting to actually actively work on those applications. And that's work led by Patrick Roche and Andrew Stubbs. And so we also have, foundational work packages. We need help with ethical and legal governance. We have a major aspect of the network is around training and outreach, making sure that not only we benefit from standard, but also we bring back to the community, and of course, project management and coordination. And if we look at the practical end-to-end implementation, so I told you about the work package structure and how each of the work package could interoperate with the GF or GH standards. But practically, in terms of the implementation, the first issue we had when we said, hey, let's just get it done, was the data. Data is hard to get by. Typically, it's controlled access. It can be difficult to get individual level data. So one of the things we had to do was devise our own synthetic cohorts for use in the Silica project. The immediate interest is that we don't have to deal with authorization, authentication. We can openly share them, not only in between Silica, but also externally with other projects. We can use them to really test the infrastructure, test the same method that we're planning to use later on with the real data. So we can test it with Beacon, we can test it with HTS-GET and so on. And another important requirement was that the metadata of the synthetic dataset needed to be representative of the core being modeled down. So quite a lot of work went into producing those 4 synthetic core datasets. One is derived from UK Biobank. One is from my colleagues in Switzerland at SIB. There's an H3 Bionet one and a child Canadian. All those datasets are available publicly, and there's more information about where they are and how they've been built, more details on the Silica website. The link is here. So this session is really about end-to-end implementation. And one of the things that we've been able to do really efficiently using synthetic data was implementing federated applications such as the federated joint genotyping done by my colleague Kirill at EBI. And he's really been able to leverage the GA4GH compatible cloud platform to deploy this workflow in practice. What Kirill has done is a 2-part process, which is the first part is private steps. So the data remains at the core site, doesn't move. And at each of the sites, the same workflow is being run to produce that little summary product that you see here in the middle. And then a second part, part B of the process, allows us to take the different resulting file, the different summary products to build a final product. There's a video done by Kirill that shows that. It's a very short video. It's only 7-8 minutes. And all the code and all the process is described on the GitHub repository as well, if you're interested in more details on those. The last part that I really wanted to talk about here today is that idea that Silica doesn't do things in isolation, because it's something that I'm really keen on, and it's really about building that shared ecosystem between Silica, IHCC, GA4, GH, and possibly future and different consortia as well. And it's really the idea that if we come together, we're much stronger. So I did mention the Silica metadata model that we've built, which we're calling Gecko for genomic knowledge ontology. And we've been using that to feed into a mapping pipeline and ingest cohort data in a standardized, harmonized way. Then in a second step, we are fairly easily, and it's not straightforward, but it's much more straightforward than if you had to redo it by yourself. We can reuse the GA4GH standard, build a shared framework for discovery and access using things like Beacon, the Connect API, Passport, the data use ontology, and we can really mesh those together to provide that framework. And finally, once we have those two pieces coming together, then we can deliver the end value for the users community. And an example of that is the work we've done in IHCC, where we've been able to produce an atlas for cohort browsing and discovery and filtering based on cohort content. And if you're interested in that, the link is there. It's an available, publicly available resource as well. And next step, we are looking now into computable cohort. Can we represent the phenotypic information of cohort? Can we derive statistics on those? This is work that's ongoing in the Global Alliance. We're co-leading with my colleague Sushil Verma. We're co-leading the effort on that subgroup. We don't quite know yet whether we need a new product, a new standard. We're really early on trying to determine whether there are resources we can reuse. We know there are, but trying to evaluate both reviewers, where are the gaps, where can we add any value? So if you're interested in that, please do join us. We are currently working on what we're calling the minimum information about computable cohorts, or MIAC, which my colleague Michael Bodis likened to the sound a cat would make, and I'm afraid that's going to have to stick. And again, big emphasis on reusing existing standards, whether it's Gecko, some other standards such as FIRE or OMOP, phenopackets to align on the payload and represent phenotypic information, and Beacon for discovery and API. And again, please, this is really a call to arms. If that's something you think you're interested, you have use case for, do join us. Contact Lindsay, she will put you in touch with the group, and you will be added to the mailing list and the group, and we'd love to work with you on those next steps, please. And so that's all I wanted to tell you about today. If you want more information, if you want to read more about the project, about Silica in particular, we have LinkedIn and Twitter and a very nice project website. Please do get in touch. We'd love to hear from you, and I'm looking forward to working with you more.
Melanie, that was a tour de force of implementation of standards, really impressive. There'll be questions for you shortly, but thank you so much. And I'm just going to move to the final speaker in this session now, who is from Brazilian Initiative in Precision Medicine, and invite Benelton Carvalho from Brazil to present to you. Thank you, Benelton.
Thank you everybody. Good morning, afternoon, and evening to everyone. I'd like to start thanking the Global Alliance for Genomics and Health for inviting us to give this talk. None of this work would actually be possible without the contributions from our colleagues here at University of Campinas. It's a whole team, but I'd like to highlight the work by Isia Lopes, Wellington, Thais Kripa, and Patricia. So what I had to show to you guys, I actually need to stop right here and just thank Melanie for her talk and let her know that I'll be in touch, because those items that she showed were actually the ones I was actually interested in working on in the next few months. So I think we are probably done here. But anyways, we have implemented actually something for our local work that we are calling Espresso Caller, but it's a GTK4 based tool that still combines WIDO and CWL to account for local requirements that we have. So the Scholar is working basically on whole genome and whole exome, and it allows for us something that is quite important, which is the use of a reference set in order to improve statistical power for genotype calling on additional subjects. This is something that is CRAM dependent, so that's actually a big step for us. Storage here is not something trivial, and the CRAM format is actually something that helped us a lot. In addition to that, we have another tool called Runner, which is a task processing system that uses TES, the Task Execution System API. It also allows for the use of Cromwell and Nextflow. And it's a tool that we use to dispatch local processing. And it accounts also for different structures, if I may say that, on computing. So we could use local networks. It would allow us to use hybrid systems, high performance clusters, and everything else. That is something that we are using quite often. And in addition to that, we are also a big fan of the beacon. We have lit our own a while ago. It's been working nicely. But we do have four main projects that we would like to highlight. The first one is the actual Bitmap samples that we've got for a while now. The second one and third, it's actually a joint effort by Thais, where we are going to be looking at Brazilian indigenous subjects and Angolan subjects. And the last one is the Jaguar Project that we got funded just a few days ago. On that sense, I'd like to remind you that the Bitmap reference samples were the first of its kind here in Latin America. The reference subjects, they were collected here in Campinas. We had exome sequenced. Pooled statistics like allele frequencies are publicly available. However, individual data like genotypes are available upon the signature of an agreement, and the management of such agreement is still done in a manual manner. Now, this is something that we already see applications for tools that have been developed under the GA4G8 framework. I'll point them out later. On the second and third projects, we need to remind you of a little bit of Brazilian history. Brazilian subjects, they have strong influence, genetic influence from Brazilian indigenous subjects, from also from Africa, and being more specific, from Angolan subjects, and also European subjects. European subjects have been known for a while that they are well characterized on omics studies. So we are focusing on the two first groups, and the idea is to study the population structure, ancestrality, and admixture. So this is something that is only possible because we've got good collaborations with indigenous students here at University of Campinas and researchers in Angola. Now, for the Jaguar project, what we are looking at is on sequencing immune cell diversity across Latin America. The samples that we're going to be using there are underrepresented populations on large genomic studies, and they will be collected all over Latin America. Mexico, Peru, Colombia, Chile, Argentina, Brazil. We are going to be looking at single cell sequencing, genotyping, admixture analysis, and we want to see how the genetic diversity adapts to the environment here in Latin America. Now, what are the tools that we foresee needing for such projects, right? We are looking for ideas and And when I say ideas, I know that Melanie has the answers already, and the Global Alliance for Genomics and Health too, but these are the items that we're going to focus on the next few months, on things that are machine readable consent. And in this particular matter here, it's something that we will also talk to legal teams, honestly, because we need consent to be, for example, consistent across different countries, in particular for this last project. We want to look at ideas, as Melanie pointed out, of federated data analysis. So encourage our collaborators to host their own data, but still make them available for data analysis by other groups. Orchestrated data processing, discovery of data like the Data Connect API, controlled data access. This is actually something that I would say it's our highest priority at this point, and make these data sets to be accessible directly from our analytical tools. And I was fast enough. So this is what I have for today. Hope you guys enjoyed and have a good day.
Milton, thank you. That was great, and great to see you forging a new partnership with Melanie and Silica. Thank you very much. We'll go now to questions, and everybody from the panel will join here. So we're going to start, Christian, with you. Now, I didn't spot this, Christian, but apparently somebody said, I'm struck by the zero number for genome-wide diagnostics in Quebec province, given its population. Are there policy or other barriers? What do you think?
Yeah, so I'll answer this one really quickly. As far as I understand it, yeah, this is a policy issue because we have, every province is responsible for their own healthcare. There's just completely different standards and policies for every province. And so it wasn't something that was funded. So this is something that's challenging, is engaging the funders to be able to ensure that this is something that's ordered. Now it's coming. It was not sent out of country previously, but it is coming.
Okay, that's very helpful. And also for you, Christian, there's a remarkable lack of these GAP programs. I'm going to ask you to define GAP in a minute, just for the audience. In the north, so Yukon, is it Northwest Territory or none of it? The population is small, but this seems surprising. So this is about geographic coverage. What do you think, Christian?
Yeah, another great question and observation. GAP is this Genomics Applications Partnership Program that Genome Canada is helping fund to kickstart the clinical implementation of sequencing. I think here we have an issue, like most of these gaps are around where there are clinical labs, laboratories that have the infrastructure to be able to provide genome-wide sequencing, exome or genome, and they just don't exist in the north, in the Northern Territories. And so, that healthcare is provided generally by the other provinces that are south. So access to specialized services would be through the other provinces.
So Christian, you don't, from the clinical angle, you're not using the CGen infrastructure then in Vancouver, Toronto, and Montreal.
That's right, Mark. So the CGen is really the research platforms, yes, genome centers that are used, and then obviously we use a lot of the learnings that we have from them in terms of how to use genome sequencing. We translate that over, but yeah, that's a research platform.
Okay, that's really helpful. Thanks, Christian. Melanie, now for organizations who'd like to adopt Silica's cohort description standards, is there a way to test for interoperability without being a Silica member? So this may be from continents where Silica is not represented. So over to you, Melanie.
Yeah, of course. That's a great question. So one of the things that I guess I'm particularly proud of is that everything we're doing in Silica, and actually the same for GH, is that it's all open and public. So the Gecko standard for code description is available publicly. It's being reused, for example, in that computable cohort work I was talking about. I will put the links to the GitHub repository, and we've also, as I said, we've reused existing standards. So we've looked in particular at Maelstrom, for example, in North America, if that's other things you're familiar with. But yeah, everything is available publicly and can be tried out. And we'd love to hear feedback, if any.
No, that's great. And I'm really delighted with your open invitation to everybody to get in touch. And then there's a question to you, Melanie, again. Is the Silica infrastructure able to be scaled to include additional cohorts? What's the limit? Is IHCC part of Silica or the other way around?
Thanks, Catherine. That's a really good question. So practically, they're different projects in the sense that IHCC focuses on cohorts that have over 100,000 participants, which is not Silica's case for most of the cohorts. So at the moment, they're separate entity, but they're using the same pipelines and standards and infrastructure. So, it wouldn't be a big leap of faith to think about an overarching umbrella and you just tag IHCC, Silica, GHIF, or GH. That wouldn't be a big leap. I don't know if Peter wanted to comment on future plan for IHCC, but yeah.
Yeah, I would just say that the International 100K Cohort Consortium is essentially powered at the moment by Silica and by work done at OICR and EBI on building the atlas. So IHCC is a big open community, and we're looking for either large cohorts or smaller cohorts from underrepresented populations.
Okay, that's very helpful, Peter. And another question for you, Melanie. Is synthetic cohort data generated from real data augmented or completely synthetic? If the former, are the privacy concerns?
It's a great question. I will put a link to the specifics of the synthetic data generation in the chat for everyone. The answer is that it's somewhere in between, in that it's coming from real data, which was processed using specific tools, different tools by different cohorts. The one I'm most familiar with is the TOFU tool, which was used by my team for the UK Biobank. It's something done by Spiros Demaxas. And it's taking the public UK Biobank showcase data set and producing synthetic data based on that. So it is based on real data because we want it to be representative of real data, but it is completely randomized and anonymized. We did look at having specific proportions of disease representation, though. So it's representative, anonymized data.
Thanks, Melanie. And Benelton, for you, the Jaguar project seems like a perfect use case for GA4GH standards. Does it take much planning ahead to set up the analysis infrastructure?
Actually, I don't think so, Mark. This is something that we could make use of public data sets, for example, to set up the analytical part. And it's just a matter of synchronizing the work between the different analytic teams that we have across the different countries. Totally possible, and I think this is actually one good opportunity for us to put in practice and publicize a little bit more the great work that Globalize has been doing.
Thank you. One final question to Yuichiro from me. Yuichiro, are you planning to convert what's essentially sounded mostly like genotype data into whole genomes or exomes, or is that a work in progress?
Yes, we are planning to do whole genome sequencing. I'm not sure about the number, but yeah, yes.
No, that's great. Well, I'm going to, on behalf of Catherine and I, thank every speaker in this session. That was fabulous. It was particularly good to see standards being implemented, and so many of them. If those of you attending are interested, get in touch with the speakers here, please, through Lindsay or directly yourselves. But I thank everybody in this session. And I'm going to move us to the next session, if I may. So We're going to look at now. Where's this gone? Okay. So we're now going to go to the GA4GH starter kit, simplifying standards implementation, and it's a pleasure to invite Jeremy Adams to speak to you. Thank you, Jeremy.
Thank you very much, Mark. Hi, everyone. Thanks for giving me the opportunity to speak with you today. I'm Jeremy Adams. I'm a senior software developer on the GA4GH staff technical team based at the Ontario Institute for Cancer Research in Toronto, Canada. And today I wanted to talk a bit about the GA4GH starter kit. So just a quick note that I'll be referring to some tutorials that you can run through on your own if interested. You can access those resources from the links in this slide deck, or you can just visit the website directly at https://starterkit.ga4gh.org. Okay, so what is the starter kit? Simply put, it's a suite of open source applications. Each app in this series acts as a server implementation of a GA4GH API specification. You've heard about them a lot already, such as Data Repository Service or DRS, Data Connect, or Beacon. We wanted to ensure that there was a simple and comprehensive example of our API specs working together as both an educational resource and an on-ramp for newcomers. So complementing the driver projects that you've heard a lot about that are implementing GA4GH standards on a massive scale and on massive data platforms, the starter kit sits towards the other end of the spectrum, and it's suitable for small to medium-sized environments, such as pilot projects or university labs, for example. The starter kit doesn't leverage any specialized cloud resources. So in that sense, it's not optimized for any particular platform. But the key here with the starter kit is versatility and simplicity. So it's possible to deploy the starter kit to get up and running with GA4GH APIs in a variety of contexts, the simplest being your local laptop or a high performance compute cluster or a cloud-based setup like on AWS or Google Cloud. So we hope this resource will reduce the barrier for members of the community to dip their toes into standardized genomics. So the core documentation is located at starterkit.ga4gh.org, as I mentioned. From there, you'll get information on how to download, configure, and launch the various starter kit apps. For anyone interested in the audience, we recommend that you run through the quick start tutorial video. It's playing right now on the right. The tutorial gets you to set up and run the DRS API on your local laptop, then execute some API calls to access metadata and raw data of a simple test data set using the DRS specification. We also have a more complicated cookbook section, which provides interactive demos for more complex tasks involving multiple GA4GH APIs. Basically how this works, the tutorials get you to set up a local network on your machine and then execute API calls to each server in the network to accomplish a demo use case. The current cookbook gets you to run a simple workflow to count the number of reads in a BAM file using calls to the GA4GH Workflow Execution Service, or WES API, using DRS to keep track of input file locations and do the file location resolution for you. So we'll add more cookbooks as new use cases become standardized, such as the token exchange between the GA4GH passports standard and DRS for controlled data access. This is a key area within multiple GA4GH standards working together to accomplish a more complex task, and it involves updates to the current GA4GH standards. So through this cookbook section, we hope to provide a library of data sharing challenges that have been solved by GA4GH standards, and for the starter kit to provide a simplified reference model of how these solutions work in practice that anyone can walk through themselves. Just to give a quick technical overview, the suite of starter kit apps are available as Docker images. We recommend using Docker for ease of use wherever possible, but of course the source code is available for environments that can't make use of Docker for whatever reason. The APIs are backed by a relational database schema. Currently, SQLite is supported for development environments, and Postgres is used for more productionized environments. And we have scripts for setting up the table schema and populating it with development or test data on a target database of your choice. We've also developed an administrative user interface for creating and editing GA4GH data models, such as DRS objects via forms, and that's what you see on the right. This enables anyone to apply GA4GH standards to their own data sets without requiring pre-existing knowledge of the underlying data models and how everything's working behind the hood with the starter kit. So I mentioned earlier that we're looking to deploy the starter kit at different sites, especially to demo GA4GH standards working in non-cloud native contexts. Lately, our focus has been on running a novel workflow on the high performance compute cluster at the European Bioinformatics Institute, EBI. CNEST, which is the name of the workflow, it's a novel copy number variation analysis developed by Tom Fitzgerald and Ewan Birney. We've deployed a mini virtual machine cluster at EBI that mimics the job submission capabilities of the production high performance compute. And we set up the GA4GH starter kit apps, WES for workflow execution and DIRS for the data repository service. So we've set those up so that we can launch the CNS workflow remotely with just using a few API calls according to the GA4GH standards and the processes that they outline. The developers of CNEST have also written a version of the workflow that's been deployed on the Terra data repository. We plan to run the workflow independently at both of these sites and demonstrate how GA4GH standards enable real-world science in both HPC and cloud-based environments, and that there's interoperability and reproducibility of results regardless of where the workflow is run. And using multiple implementations, there can still be reproducibility of results. Another opportunity for deployment of the starter kit and piloting it has come up in discussions following GA4GH 9th plenary, which was back in September. So I should note that this work is in the very early conceptualization stage. Melissa Klein from Bracket Exchange is looking for ways to federate the execution of a workflow that summarizes it runs a summarization analysis on variants of unknown significance, or VUS. Due to data privacy laws and considerations, the sites in the International Bracket Exchange Network cannot aggregate all of the raw data to a single location for it to be analyzed. Rather, each site must first summarize the data internally, at which point the summaries can be exchanged throughout the network. So Bracket Exchange is interested in leveraging the Workflow Execution Service API to enable distributed and interoperable workflow submission on each site. We plan to use the starter kit WES implementation to facilitate this use case, especially as only some sites in the network currently have a WES server available to them and some do not, and that's where the starter kit deployment comes in. So this will demonstrate interoperability between the starter kit and other implementations of the WES standard that are going to be used for this project. The Federated Analysis Systems project, just wanted to give a quick talk about this. Federated Analysis Systems Project, or FASP for short. It's a GA4GH community in which scientific use cases requiring standardization and federation are demoed on real-world data platforms, such as 7 Bridges, Elixir, and DNA Stacks platform. In previous years, we ran what we called the horizontal and vertical demos to demonstrate workflow interoperability and reproducibility of scientific data. In 2022, so in the upcoming year, we plan to conduct what we're calling a challenge testbed, where data providers will need to update their platforms to fulfill new use cases outlined by new versions of both the DRS and passport specifications. And those new versions are still in development. So it's quite a bit of a moving target. These new features that are projected to be released in the new versions, they'll essentially enable a researcher to obtain an authorization token, that being a series of passport visas according to the passport terminology. And that set of authorizations is specific to a set of data that the researcher is interested in. So it's scoped so that it enables access to the requested data set and nothing greater or beyond that. So we plan to have the starter kit participate as one of the data platforms in this 2022 challenge, and give anyone the tools needed to run through the challenge themselves and take the lessons learned back to their home organization and their own implementations that they're working on. We're even considering a novel use case, which we're calling Federated Authorization, a federated auth component to the challenge, in which passport visas from a GA4GH maintained passport broker deployed by the starter kit would be needed to gain access to a synthetic test data set stored on a different platform. So just to wrap up a bit here, our team essentially is looking to expand the capabilities of the starter kit, especially by implementing more API specs beyond just DIRS and WES. Passports is the current priority because that will enable all of the controlled data access demos and scenarios that I mentioned. But it's essentially on our roadmap to implement all the GA4GH APIs because there's a variety use cases that people are interested in, and various APIs to do various different tasks. We'll be supporting the starter kit for the foreseeable future, and we definitely plan to stay one-to-one with the existing APIs as new features are developed. So when DIRS version 1.3 comes out and Passports version 1.2 comes out, we plan to update our code base to stay in line with all of those new features that are released. The main thing we're interested in getting is getting the starter kit deployed at other sites for other use cases. Even if this is just a very simplified, scaled down demo or a temporary solution, the starter kit can help serve as a transitional on-ramp as an organization develops more sophisticated implementations that are tailored towards their use cases and infrastructure. We've conceived of a second phase to the EBI CNES demo that I mentioned, involving passports, which would essentially allow people acting as users to gain access to a first controlled data set and then run the DIRS and WES execution demo. That's essentially my call to action in this talk. If you think that the starter kit is relevant and it might help in helping you get up and running with GA4GH standards at your own institute and for your own research purposes, please reach out to me at any time and let's collaborate. And I think that's it for me, so I'll wrap up here. Thank you very much for your time, and if there's time, I'm happy to take questions. Thank you.
Jeremy, thank you for a great talk, and we will let you take some questions if there are any in the Slido. I was just going to make an observation. So there's a comment that's first up, which is really praise, if I'm honest, and thanks to you, Jeremy. So thank you on behalf of all of us for creating the starter kit, and it's a nice resource. So is any of the starter kit components used for production, or is it all just a starting point?
So, I mean, I would say currently it's not being used in any production system, but the goal here would be to provide an on-ramp so that, you have production components that are sort of doing one thing, and then, you want to explore how another GA4GH API would augment or complement, your current setup. So I would say in that sense, it can complement what's already being done in production to facilitate new avenues of research and of data processing. But it's I guess getting things productionized and making it production ready in all environments is not necessarily the goal here. Although if somebody was to really take the starter kit and really want to productionize it for that system, that's certainly an avenue, and it's all open, and people are welcome to take that code and tailor it to their own use case and productionize it for their own platforms, for sure.
Very clear, Jeremy. I like your focus on CNEST. I've had some limited experience with Tom and Ewan on looking at CNEST in COVID-19, and I think it looks very promising. So everybody who's interested in that aspect, open offer from Jeremy to perhaps join in at a later stage when in testing it. And Jeremy, did you want to say a little more about how it works at the moment, just so, because I think a lot of people may not have heard of it.
The CNEST workflow specifically?
Yeah. Yes.
I'm probably not the best person to answer that, but this was essentially came to us from Tom and Ewan about it being an ideal use case for deploying the starter kit. So it's essentially a workflow that runs copy number analysis and classification and gender classification and a bunch of other classification statistics on a set of input CRAM and CRAM data. And so we've essentially, that workflow has been wrapped in workflow languages like Common Workflow Language, Workflow Description Language, and Nextflow. And the WES API has been deployed at EBI to essentially wrap all of that functionality so that it can be executed remotely. So the Workflow Execution Service API is essentially a REST API for submitting jobs using simplified API calls. So specifying, I want to run such and such a workflow on such and such input parameters, using remote calls to various servers and data sets that might be remote. So we've essentially deployed Wes Starter Kit to do all of that upfront work, and then the other tools that are sort of downstream of that, it gets it runs the execution downstream of that. And so I mentioned that we set up the cluster up to mimic the production HPC. So we're using Slurm, which is a job scheduling engine that's being used on EBI. So the Wes Starter Kit sort of plugs into Slurm to leverage all of that job submission capability.
Excellent, and thank you for an excellent talk, Jeremy. There are no more questions on the Slido. So everybody, on behalf of Catherine, myself, and Peter Goodhand, CEO of Global Alliance for Genomic Health, thank you for joining today. I should also take this opportunity to record our thanks to all the speakers who've done an amazing job today. So encouraging to see the implementation of the standards. But I'd particularly like to thank Lindsay Smith, Angela Page, and Justina Chung for all their effort that goes on behind the scenes, which you don't see, that makes this work. And thank you for all you've done today to make these two sessions work for Genomics in Health Implementation Forum. We would like to hear from you as members of this forum of suggestions for future fora. So Catherine, me, Lindsay, please send in your suggestions. If you've got an idea for a session, or you've been working away on a standard and would like to share your experience, we'd love to hear from you. And now I'm going to give you 8 minutes of your life back. Thank you very much for joining today, and particularly those who stayed up after midnight. Thank you all. Bye now.